I have shown all the execution using S3 event data only, and this is how the S3 event data looks like. And we have seen that using the print statement also. We can get similar event data from Kinesis, we can get event data from SQS, Kafka, and all the other services that were there. The only difference would be that the structure of the event data would be different. Now, in this case, you see the Kinesis event data, there are multiple records. Record is an array, and the first element contains one data, second element contains second data. So in case of Kinesis and Kafka, you can expect the records array to contain a lot more records than S3 event data. And that is only normal because these are stream ingestion frameworks or technologies. So we will be expecting a lot of records. If you want, you can try with Kafka, sending data to Kafka, and then that should trigger a Lambda function which would contain Python code. But you cannot run PySpark code. Now let me try to understand some of the architectures using Lambda. This is what we have done so far. We have uploaded files to S3. It can be using API, it can be using FTP, or it can be using SDKs also. Now once we upload the file to S3, it would trigger a Lambda function, and the Lambda function can write to S3, can write to database, or send it to SQS also. In our case, we had written the processed data by removing the PII in S3 and also to database. Similarly, we can write it to SQS also. For the downstream applications, Spark can read records from S3 or database and then continue the entire data engineering pipeline. In the second case, for SQS, there can be another Lambda code or Lambda function or an application which would read records from SQS and might send it to S3 or database, and then Spark can come in and read the records from there and continue the data engineering pipeline. So you see, Lambda sits mostly at the beginning of the data engineering pipeline. In the second diagram, so we can have records from Kinesis, Kafka, SQS, or NoSQL databases. So we can have Lambda as their triggers. Now from here, the Lambda function can read the records, store it in S3. From SQS and NoSQL database also, Lambda can read the records, do a very lightweight processing and store it in either S3 or maybe to Kafka or Kinesis. And from there, Spark can read the records and continue the data engineering pipeline. If it reads from S3, it would be batch processing. If Spark reads from Kafka, it would be stream processing, which you already know by now. So that's all I wanted to discuss about Lambda and the role of Lambda in the data engineering pipeline. Thanks a lot, and I'll mention it again. Let us try to save animals of the earth, because if you do not have any animals, there won't be any humans also. I would request you to avoid any animal products for that matter. Leather products or any products which are made using animal parts, please avoid them. That is the least that you can do. Thank you so much.